slightly different question to what I said I'd do, because that's got a cos in it. I think the last one I said I'd do, which I'm doing those later. So we're just doing the composite functions just now. So similar to the last question, but there's no limits this time. So let's set up our integral. So we'll get our sign in, and I'm going to have 5 take away 4x to the negative half. So I'm setting up my integral, and I'm integrating with respect to x. I just suddenly realised, yeah, oh, thought I forgot that on the last one, that's good. Dx, fantastic. So what are we going to do? Well, let's remember, something like x squared, if I integrate that, would become a third x cubed, because we add 1 to the power and divide by the new power. So let's add 1 to our power, shall we? So I'm going to get a half, and I'm going to divide by the new power, which is a half, but I also have to times by the differential, which is negative 4. And the other thing to watch out for this, as there's no limits, I need to add my plus c, and your bracket always stays the same. So let's tidy this up. That's going to give me negative 4 halves, and effectively there's a 1 here, isn't there? So what I'm doing is the 1 divided by negative 4 halves. So that's the same as, if we do KFC, 1 times negative 2 over 4. So that's going to be negative 2 over 4, which is negative a half. So this is going to come out as negative 5 take away 4x to the half divided by 2. It's just the same as negative a half, isn't it? I'll just write the little 1 in there just to kind of, show you, like negative 1 over 2. It's the same as times in by a half. And then don't forget your plus c on the end. So a much nicer question there. 4 marks, same number of marks as the last one. I'm guessing a lot of people fall down, lose a mark by not putting their plus c. But yeah, you're getting a mark for the setup. You're getting a mark for remembering the plus c, the dx, everything, but also multiplying or dividing by that the differential of the bracket. So as I said, really nice little question to get actually. And again, here's another one. Look at that. Does it look familiar? Yes, it does. They're all very similar. And here we're getting 5 marks this time. Very good, very good. So let's set up our integral. I'm going to have between 9 and negative 4, and that's going to be 2. I hate that box appears, it's so annoying. So that's 2/3, and when I bring it to the top, that's going to become negative 2/3. So I'm integrating this with respect to x. Okay, so on the bottom, something like this. Very good. So the bracket, I'm going to add 1 to the power. So if I add 1, I'm adding 3/3. So I'm going to end up with a third. And I'm dividing by that new power. Fantastic. The bracket stays the same. And I multiply through by the differential. So let's have a think then. That's saying that I've got, again, effectively got a 1 in here. That's like saying 1 divided by 2/3. So keep flip change. 3 over 2. So in the next line, and at this point I tend to tidy up slightly as well, because I know I'm going to be substituting. I'm going to have 2x plus 9 over 2. So that means times in by 3 over 2. And that will be to the cube root. And I'll just put that in a slightly different colour just to show you there's a little cube root in there. Okay. Nice one. And now we're ready to substitute in. So I'll say that's going to be 3 cube root of 2 9 plus 9 all over 2. We're taking away 3 cube root of 2. Again, just take your time with these. Really, all the work in. Don't be shy. Just take your time. I know it's quite boring, but the minute you rush it is the minute you'll make a silly mistake and you'll be right down a wee rabbit hole and it'll be very difficult for you. So we're hoping that these numbers come out as nice cube root numbers, So I'll get 18 and 9. So I'll get 27. So that's great. That's 3. So I'll get 3 times 3 over 2. So I've got 9 halves on this side. So you're thinking, right, that sounds good. I've got a cube root number, probably on the right lines, yeah? This one, okay, -8 plus 9, so that's 1. Cube root of 1 is just 1. So again, you're thinking, yeah, that made sense. That's fantastic. So take away 3 halves. So 9 halves, take away 3 halves, will be 6 halves. So I'm getting 3 units squared. Let's have a look, just double check my answer. Yeah, very good. So, I mean, quite boring these videos, if I'm being honest. You know, not much excitement going on. It's all about taking your time and plugging in the numbers. But each time, and that's the last one I'm going to do these, yeah. Each time you're doing the setup, you're adding 1 to the power and dividing by the new power. And then it's this bit here, which was the new bit. We're multiplying through by the differential. That's the new skill we've learned. And after here, we're substituting in. So actually not a huge amount of newness. We know how to integrate already. We're just dividing by that differential, but because we're already dividing, I'm saying multiply, sorry. Yeah. But we've got that new, the new divide by differential. Same again here, set it up, add 1 to your power, divide by the new power, then we're timesing that by the differential in the bracket. Bracket stays the same. So don't be scared of these questions, they look horrible. And again, how do we identify them? We've maybe got a fractal power or a very high power, in which case it becomes much easier to use the chain rule, reverse chain rule. You know, if we see that kind of power, we're thinking, okay, I can't break that bracket out, so I'm going to have to use my new rule. So that is us covered, and I think these are excellent questions, really. The differentiating of composite functions and the integration of composite functions. And each time, there was a few good marks. I've not seen many of the differentiation ones because they're a wee bit easier. It's more predominantly the integration ones. But look at that, it's 4 and 5 marks for quite small amounts of working. But you've just got to take your time with these and not make any silly mistakes. So really take the space on the page. Look how much space I left myself, Take the space on the page, go through it step by step. Don't rush it, be tidy, and then at the end you can check it as well. Okay. So that helps. On the next section, we're going to look at differentiating trig and then integrating trig. So please join me for the next video.